All right. Hello, everyone. I just wanted to do a quick video to go through the word problems in homework 11 to kind of help you have an idea about how to tackle these guys. So here's the first one. In this example, a pilot is flying parallel to the ocean. She determines that the angles of depression to two ships are 65 degrees and 54 degrees, as shown in the figure below. The plane is 4 miles from the ship located at point A, and how far apart are the ships? And then we'll round to the nearest tenth of a mile. Okay, so we've got some information here. Luckily, they put in these angles of depression for you because I think that's kind of a really confusing way to kind of explain this, but they put those angles in there for you, which is helpful, and they fill in that distance to ship A. What we're looking for is the distance between our ships. So ship A is here, ship B is over here. I want the distance between them. I'm looking for the length of this side down here. So I need to solve for this side, AB, in my triangle. Okay, how am I going to do that? I only have this side over here of my triangle. That's certainly not enough to solve for x down here. So we need to look for some ways to get some information about our triangle from the information that we're given. Because this pilot is flying parallel to the ocean, and this distance that we're looking for, this is along the ocean, these two lines are parallel. And something that we know from geometry, hopefully you recall this, alternate interior angles are equivalent. So this 54 degrees up here and this angle A down here by ship A, these two are alternate interior angles. They're equal. So this angle down here by ship A, that also has a measure of 54 degrees. Similarly, because of alternate interior angles, this angle here over by ship B, that's equivalent to 65 degrees up here, which is an alternate interior angle. So this angle down here is 65 degrees. And so now I've got two angles in my triangle. That means I can go ahead and solve for the third if I'd like to. So this one up here, I'm going to find that by subtracting from 180. So I'm going to do 180 degrees minus 54 degrees minus 65 degrees to get that third angle. And when I do that, I'm going to get 61 degrees. So this angle up here is 61 degrees. So now we've got all the angles in our triangle, and I need to solve down here for the side x. This is not a right triangle. This is oblique, so I don't have the Pythagorean theorem or SOHCAHTOA or any of that. But I do have the law of sines and the law of cosines. Now, if you notice, I do have angle B and the side opposite it. I have a complete ratio in the law of sines. And we just solved for that 61 degrees. That's the angle opposite the side I'm looking for. So I can set up those two ratios with the law of sines. So I'm going to do the sine of that angle B, which is 65 degrees. I'm going to put that over side B, which will be 4 miles. And I'm going to set that equal to the sine of 61 degrees. That's the angle opposite the side I'm looking for, over x, which is the length of the side that I'm looking for. So this is the law of sines that we use to set that up. And now we can just go ahead and solve this. You can cross multiply here, or you can multiply both sides by your least common denominator of 4x. Either way you go, when you do that, you're going to get x times the sine of 65 degrees is equal to 4 times the sine of 61 degrees. And I'm solving for x here, so I'm going to go ahead and divide both sides by the sine of 65 degrees. And that means x is equal to 4 times the sine of 61 degrees all over the sine of 65 degrees. That you can kind of plug and chug in your calculator. When I did that, I got 3.86. So that means the length from A to B is 3.86. And we're going to have to put units on that. Our distance here is in miles. So this is going to be in miles, and it says round your answer to the nearest tenth. So I'm going to round to this place right here because that number after it is bigger than a 5. I'm going to round it up. So my answer here is going to be 3.9 miles. That is the distance between the ships. So the big thing here was using those alternate interior angles to start forming some information about our triangle. And then once we have those angles, then we can kind of fill in the information so that we get a complete ratio for the law of sines that we can set equal to a ratio with the side that we're looking for. Okay, and then one last word problem here. All right, so this time we have airplanes instead of, well, I guess we had an airplane in the last one too, but we don't have ships in this one, I guess. An airplane leaves City A and flies 144 kilometers due north to City B. It then turns through an angle of 54 degrees. That's labeled right here. And it flies 119 miles to City C. What angle theta, with respect to due north, could the pilot have used to fly directly from City A to City C? Round your answer to the nearest tenth, and then any intermediate rounding take to 4 decimal places. Okay, again, luckily they label this for you because I think that the wording that they use is kind of confusing. So basically this plane flew from City A to City B. It turned through this angle here and then flew to City C. And it wants to know, if I flew directly from City A to City C, what is this angle here between due north and that kind of that line that it would take from A to C? All right, so I'm looking for that angle down here. And how am I going to find that? I have 2 sides of my triangle, and that's it. So I'm going to need a little bit more information about my triangle before I can start trying to solve this. So something that I notice here is we are given this angle here, that 54 degrees. That does tell us something about this angle of our triangle here. Because this is a straight line, then that entire angle there is 180 degrees. Since 54 degrees takes up that top part, this bottom part down here is going to be 180 degrees minus 54 degrees, which will leave us with 126 degrees. So that's how big that angle in here is. So now I have an angle and 2 sides. If I look a little bit closer, I've got 2 sides and the angle between them. That's a side angle side situation. And I solve that using the law of cosines. So I'm going to solve this guy using the law of cosines. And with side angle side, what we're going to be doing there is using our the information that we're given with the angle that we have. So I'm going to say if this angle here is angle B, then the form of the law of cosines that we'll use, and I'm just going to say it's angle B because it's labeled as City B, so I'm going to call that B. I'm going to choose the law of cosines with angle B in it. So that's going to be B squared equals A squared plus C squared minus 2AC times the cosine of angle B. And again, I have these two labeled, that's city A and city C. So I'm going to call this, that theta, that's going to be angle A, and then angle C is going to be up here by city C. So that means that my 119, that is side A, and this 144 kilometers, that is side C. So I can go ahead and plug in what I have and solve for what I don't. That means this side B over here, B squared is going to be equal to A, which is 119 squared, plus C, which is 144 squared, minus 2 times A, which is 119, times C, which is 144, times the cosine of angle B, which we just calculated was 126 degrees. You're just going to plug all of that into a calculator. And when you do that, you're going to get B squared equals, when I plugged all of this in, I got 234. Oh, that's A. So hold on, sorry about that. So I had taken this all the way to the end, but I'll give you the intermediate here just to make sure. So minus 2. Apologies for the delay here. Okay, so when I put this in a calculator, I get, here we go, 55,041.57617. I'm going to take the square root of both sides, and when I do, I get 234.6094. So that is side B here. And again, that's in kilometers because that's a side B. So that's the length of this guy over here. Now that's not what I was looking for, but now I have more information in my triangle. And this allows me to have a complete ratio in the law of sines. I now have angle B and side B opposite it. So I have a complete ratio in my law of sines. So now I can use the law of sines to solve for this angle theta down here, which is what I'm really, really looking for. So I'm going to say the sine of angle B, which is 126 degrees, over side B, which I just calculated here was 234.6094. That's going to be equal to the sine of the angle that I'm looking for, which is theta, over the side opposite that angle, which is 119. So we can set this up, and now that we have this set up in the law of sines, we just have to solve this out. We've been doing this a lot, so hopefully you are okay with me kind of going through this quickly. This is 119 times the sine of 126 degrees, all over 234.6094. So I did a couple steps in my head there, but basically you're going to either cross multiply and then solve for sine theta, or you're going to multiply both sides by 119 times 234.6094, multiply both sides by that LCD and simplify, and then solve for sine theta. You should get this when you're done with that. When you plug that into your calculator, I got 0.4104. So to get to the angle theta, I need the inverse sine. So theta is going to be equal to the inverse sine of that ratio. And when you plug that into your calculator, what you get out is 24.2271 degrees. Um, and we don't need to check our quadrant 2 solution. Um, Mostly that's just because of the way that this is all drawn out. Because I have an angle of 126 degrees in my triangle already, this cannot be an obtuse angle. It must be acute. The only solution that we'll have for that is in quadrant 1. So I don't have to bother checking my quadrant 2 solution here. And so that means that the angle that we're looking for is 24.2271 degrees. And Alex is going to want you to round that to the nearest tenth of a degree. So when you put that into Alex, it's going to be 24.2 degrees. All right, we're rounding to the 10th. This is less than a 5, so we're going to leave it as is. So that's what you'll put into Alex. Hopefully that helps you with your word problems. If you have any issues with homework 11, please let me know. It's due on Monday at midnight. I hope you have a lovely weekend, and I'll see you next week on Tuesday.